Hello, so today I'm going to be talking about nuclear chemistry. Nuclear chemistry is a difficult topic to do any sort of experiments on or anything like that, just because if you don't know what you're doing or how you have to handle certain chemicals, it can be dangerous because those chemicals can explode and can be radioactive, and it is really not a good thing to work on radioactive chemicals or anything nuclear if you're not in a lab or a scientist who knows how to handle those certain reactants that you will be using. So the United States was the first country to develop nuclear weapons and to figure out nuclear chemistry because they detonated the first fission device in 1945. Nuclear chemistry is a subfield of chemistry dealing with radioactivity, nuclear processes such as nuclear transmutation, and nuclear properties. And how I said before, nuclear chemistry is hard to do any experiments on because it can be dangerous for the person doing it or the person around them or the person even near them because it's very powerful, and if something did go wrong, it could affect a ton of people. And it's something that even scientists, like even when they're in the lab, they must be extremely cautious, or even workers working on nuclear power plants. They have all their procedures and things can still go wrong and just really do a lot of damage. Nuclear chemistry is something that has been a great advancement over the last few decades, especially medically with treating patients, like giving radiation to cancer patients. I think just getting better on the MRI scans and the CAT scans, or just all around medically, have been helping people. But it's also caused a lot of negative things because with knowledge of something that powerful, it could also lead to a lot of problems. And the immense destructive power of atomic weapons derives from a sudden release of energy produced by splitting the nuclei of the fissile elements making up the bomb's core. So usually nuclear fission occurs in nuclear chemistry. Nuclear fission is the process in which a heavy nucleus, or the mass number is greater than 200, divides to form smaller nuclei of intermediate mass and one or more neutrons. And because the heavy nucleus is less stable than its products, this process releases a large amount of energy. The first nuclear fission reaction to be studied was between uranium-235 and plutonium-239, and they were chosen because they both readily undergo fission. Although many other heavy nuclei can be made to undergo fission, the reaction that really matters is the one that is occurring between the naturally occurring uranium-235 and plutonium-239. A representative reaction that occurs between uranium-235 is 235 over 92U plus 1 over 0N equals 90 over 38SR plus 143 over 54XE plus 3 1 over 0N. The fission process becomes self-sustaining as neutrons produced by the splitting of atoms strike nearby nuclei and produce more fission. This is known as a chain reaction, and it's what causes an atomic explosion because not just one goes off, but then all of the other ones go off, and it just causes it to be really powerful and really strong. And the magnitude of the energy is found by looking at the differences between the binding energies of the reactants and products, which is 1.23 times 10 to the negative 10 plus 1.92 times 10 to the negative 10 joules minus 2.82 times 10 to the negative 10 joules. And it could also be looked at by doing 3.3 times 10 to the negative 11th joules per uranium-235 nucleus. So that means for 1 mole of uranium-235, the energy release would be 3.3 times 10 to the negative 11th times 6.02 times 10 to the 23rd, or 2.0 times 10 to the 23rd joules. This reaction that occurs is extremely exothermic. So uranium-235 makes a nuclear chain reaction possible because it has more neurons that are produced than are originally captured in the process. A nuclear chain reaction is a self-sustaining reaction sequence of fission reactions. During the initial stages of fission, the neutrons that are generated can induce fission in other uranium-235 nuclei, which can then produce more neutrons and so on. And in less than a second, the reaction can become uncontrollable, releasing a large amount of heat to the surroundings. And this is really dangerous because once nuclear reactions go off, they are hard to stop or put out. It's just a huge explosion that's going to occur. Uranium is found throughout the world and can be mined from several deposits. However, only a small fraction of naturally occurring uranium is uranium-235. And plutonium can be used but only occurs naturally in trace amounts. So the first application of nuclear fission was in the development of the atomic bomb. So it said most of the nuclear reactors in the United States are light water reactors. And the speed of the neutrons is a very important part of the fission process because slow neutrons split uranium-235 nuclei more efficiently than do fast ones. And the neutrons produced usually move at high velocities because fission reactions are highly exothermic. And scientists use moderators to reduce the kinetic energy of neutrons because this will ensure greater efficiency. Plutonium-239, which I found interesting, as a nuclear fuel and produced in breeder reactors, is one of the most toxic substances known, and it is an emitter with a half-life of 24,000 years. Though many people are against nuclear chemistry because of the dangers that can occur, accidents happen, and unfortunately with nuclear chemistry, this can be detrimental and horrific for the people nearby because having a radiation fallout could cause a number of medical problems with people such as cancer or cardiovascular disease or a bunch of other problems. And another problem with nuclear chemistry is radioactive waste disposal, which has not been satisfactorily resolved, even for nuclear power plants where they're doing everything under the right procedure and doing everything like that. And I think because of all these problems, the advancements in nuclear chemistry is uncertain, and it's hard for scientists to really explore nuclear chemistry just because there's so many factors that go into it, such as the cost and how dangerous and how hard it is to work with uranium-235 and plutonium. And I think those factors really are going to keep affecting how scientists discover new ways for atomic explosions and how they have been affecting them and holding them back.